Hi, everyone. Today we are talking about 2.6, solving absolute value inequalities. So we've got four categories that we're going to look at today. Our first category is when we have an absolute value that is less than a positive number. So what that's going to result in is one of our and categories of inequalities, which means that when we get to graphing, we're going to be shading in the middle. And we're going to write our inequalities as sandwich style. So to get our two answers, we are going to be splitting into two different inequalities. So here's our example to start off with. We've got the absolute value of 2x minus 5 is less than or equal to 3. First thing you want to check is the number at the end. Because we are less than a positive number, in this case, positive 3, this is going to fall into the and category. Our first inequality we're going to set up. We're going to take the 2x minus 5 less than or equal to 3. And then we're just going to solve as normal. So I would add 5 to both sides. And then my last step, divide both sides by 2. So we would get x is less than or equal to 4 for our first answer. Then we're going to have another side. So this is where we're splitting into our two separate inequalities. The second side is going to be similar with slight changes. So on this side, we're still going to have our 2x minus 5. But two things happen. First, our inequality is going to flip. So instead of being a less than, now it's greater than. And then we're going to change that number at the end to be a negative 3. Then we're going to solve as normal. So add your 5 and divide both sides by 2. So our answer on that side, we get x is greater than or equal to 1. So for our final answer, we're going to write it sandwich style. So a reminder on that, your lower number goes first. So our positive 1 goes first. X is sandwiched in the middle. And then our higher value goes last. And then when we write it in sandwich style, remember, it's always going to be two less than symbols. And in this case, they're both less than or equal to. Graphing our solution on the number line. There we are. So we've got closed circle both at 1 and 4. And then because this was an and, we need to be shaded in the middle. For our next category, this is when we've got an absolute value, but this time it's greater than a positive number. That's going to fit into our or category of inequalities. And if you guys remember from our previous lesson, with an or, we are going to shade the ends of our number line. So just like with the and situation, the ors are also going to split into two inequalities, and it's going to split exactly the same way. So here's our example. We've got absolute value of 4 minus 8x, and that is greater than 12. Always check that number at the end first, just make sure you're in the right category. So we've got an absolute value greater than a positive 12. So we are going to be in our or category. Solving our first side, 4 minus 8x is greater than 12. So nothing really changes on that side except just dropping your absolute value symbols. And then let's solve. So subtract your 4 on both sides. And then divide both sides by negative 8. Hopefully remember our little extra rule with inequalities. When you divide both sides by negative, we are going to flip the direction that our inequality is opening. So our final answer on that side, x is now less than negative 1. All right, on to our other solution. We're going to keep our 4 minus 8x the same, but this time we are going to flip our inequality so it becomes a less than. and change the number at the end so that it becomes a negative 12. Solve as normal, subtract your 4, then divide both sides by negative 8. And again, we're going to have flipping happen for our final answer because we just divided both sides by a negative. So the final answer, x is now greater than 2. Putting our two solutions together, x is less than negative 1 or x is greater than 2. Let's get our answers on the number line. Both are going to have open circles because they were ones without the or equal to part. So both open circles, and we are shading the ends. All right, category 3. Category 3 and 4 are going to be a little bit different than 1 and 2. So for category 3, now we're going to have an absolute value that is less than a negative number. That's going to result in no solution. And the reason it's no solution is similar to what we did when we solved absolute value equations. We always check to make sure our absolute value was equal to a positive because absolute value is distance and distance can never be negative. So what this statement is saying is we've got a distance that is less than a negative number, which is impossible, which is why it ends up being no solution. And what that answer is going to look like on the number line is it's going to be totally empty because there's no solution possible. All right, here's our example. Absolute value of x plus 1 and then minus 5 is less than negative 7. First thing to do here, our absolute value is not isolated yet. So we need to make sure to get that absolute value alone before we do anything else. To do that, we're going to add our 5 to both sides. And here's our result. Now we've got absolute value of x plus 1 is less than negative 2. Check that number at the end. We've got an absolute value less than a negative number, which means this is going to be in our no solution category. So our graph would just be a totally empty number line. There's no solution. Our last category is when our absolute value is greater than a negative number. This is going to result in infinite solutions. And the reason we get infinite solutions is absolute value is always going to be greater than a negative number, right? Because absolute value tells you distance. Distance is always positive. So anytime you've got your absolute value greater than a negative, that means that it was infinite solutions, which means our entire number line would end up being shaded. Here's our example. Absolute value of 7x, then plus 3 is greater than 2. Just like the one before, we need to get those absolute values alone first. So subtract your 3 on both sides. Then we get absolute value of 7x is greater than negative 1. Checking that number at the end, we've got an absolute value greater than a negative, which means it falls into that category of infinite solutions. So our number line, the entire thing's going to end up being shaded to show that all the solutions, all of our numbers are going to work. All right, that is it for today. Hope you guys have a great rest of your day.